Good morning everybody and welcome to my channel. Today we're reading Telangana State Syllabus SCSE Chapter 1 10th class Reflection of Light at Curved Surfaces. In class 7th and 8th you learned about the image formation in plane mirrors. You also discussed about the spherical mirrors. You know that why the curved surfaces are known as spherical mirrors. Today in this chapter we'll be discussing mostly about spherical mirrors. Now you might have got many doubts while observing your image in bulged surfaces. Like sometimes it comes inverted, sometimes erect. That's what we are going to learn in this lesson. We are going to learn in this lesson about how the image is formed on a curved mirror and how it reflects light rays. So is the image formed by a bulged surface same as the image formed by a plane mirror? No, it's not. Is the mirror used in automobiles a plane mirror? Why is it showing small images? Is it? That is what we are going to find out in this chapter. Why does our image appear thin or bulged out in some mirrors? Is it because those mirrors are curved mirrors or plane mirrors? Can we see inverted image in any mirror? No, we cannot. Can we focus sunlight at a point using a mirror instead of magnifying glass? Are the angle of reflection and angle of incidence also equal for reflection by curved surfaces? So, you might have read about angle of reflection and angle of incidence in 9th class if I'm right. So, in a plane mirror, they are always equal. But what about curved surfaces? Are they equal? Now, let us discuss about the reflection of light by spherical mirrors in this lesson to get clarity for the above questions. So now let us take a quick summary about curved surfaces on our whiteboard. Let's draw our curved mirrors. Okay, so now we have got our curved mirrors. Let's draw the reflecting surfaces. Our reflecting surfaces. Okay. So the middle point of the curved surface is known as the pole, the point I made. You can see it is represented as P. And now we can draw a line going from the pole to stretching to the center of curvature. Now what's the center of curvature? The center of curvature is the center of the sphere of the mirror. See, actually a curved mirror is a part of a big sphere, and the center of the sphere is known as the center of curvature or C. Now let us take a look at the definition of the principal axis. Principal axis is the line passing through the pole and the center of curvature of the mirror. This line is called the principal axis. Now what is the pole of a spherical mirror? It is the midpoint of the spherical mirror. As I showed, it is the center of the spherical mirror, not the center of the sphere. The center of the sphere is known as the center of curvature. It is the center of the sphere of which the mirror forms a part. That means the mirror is a part of a sphere, and the center of the sphere is known as the center of curvature. Now, what's the radius of curvature? It is the radius of the sphere of which the mirror forms a part. See in this diagram you can see here, that is the curve of the mirror, and this is the sphere of which the mirror is a part of, and the radius of curvature. This is the line extending from the pole to the center of curvature. Now some of you will say the principal axis and the radius of curvature is the same. No, it is not the same. The radius of curvature is extending from the pole till the center of curvature, but the principal axis, it is a line passing from the through the pole and through the center of curvature. It's not like it should only stay till there. It can even go beyond. Let us get back to our whiteboard. Okay, and now let's draw our center of curvature, we draw some parallel rays going towards the mirror which are parallel to the principal axis. Alright, now see, all these rays are converging towards a single point which is between the pole and the center of curvature. This point is called the focal point or the focus. Okay, we can also represent it as capital F. 2 times the focus is equals to the radius of curvature. Okay, 2F is equals to C. Now let us just see the correct exact definition of the focus or the focal point. It is a point on the principal axis where a beam of light parallel to the principal axis either actually converges into a point called the focus or appears to diverge from after reflection from the mirror. So what it's trying to say here is that a beam of light parallel to the principal axis either actually converges into, so we are shooting a beam of light towards the mirror and it converges into a point called the focus, or it actually appears to diverge from the reflection of the mirror, or if we shoot a beam of light from the focus, it will actually appear to diverge from the mirror. Alright, got it. Let's head to the next topic. Let us bring our whiteboard. The mirror which I showed you before was a concave mirror, and now I will show you a convex mirror. There are 2 types of spherical mirrors. There is concave and convex. This one here is a convex. Let's draw our rays. Okay, and let us put all these rays here. Wait, always draw the principal axis first. Always. Let's draw our pole. Let's draw our focus where all the rays are going to meet. Let's draw our center of curvature, and let's make all the rays meet there. Yes. Okay, all the rays meeting at the focus. Now you see, it's the same thing here. All the rays parallel to the principal axis, they're going and meeting at the focus, because over here also they're parallel to the principal axis. Now let us remove that. Let's draw again our convex mirror, our principal axis always first, and then our pole, our focal point, and then we can draw our center of curvature. And now, as you can see here, if a ray in our concave mirror, let us see, the ray is going parallel, and then they both will go towards the focal point or the focus. The rays are going parallel and going back towards the focus. So like if we keep an object and the rays come from that side parallel to the principal axis, the image will be formed at the focus. Alright? And if a ray is going from the center of curvature, along the center of curvature, hits the pole and comes back as it is from the same direction it went. Alright? And now if a ray is going towards the pole, it will go back with the same angle it came. For example, here we take an angle of 45 degree. Alright? We take a 45 degree angle, then it goes back with the same angle of 45 degree, because the center of curvature acts as a normal for it. Now let us draw our concave mirror. Let us draw our pole. Let's draw our principal axis, our focal point, and then let us draw our center of curvature. For example, a ray is going somewhere here, alright? Somewhere from here. It's not parallel to the principal axis. Let me do this. Alright? Then, how do you measure it? You will have to draw a normal. A normal meaning the point where the ray touches the mirror to the point till the center of curvature, a line from that area. So you measure the angle from the normal to the ray, incident ray, and then for example let's take it 60 degree. So then that one will get reflected by again 60 degree from the normal. Alright? Now let us see what focal length is. The focal length is the distance between the principal focus and the pole of the mirror. So principal focus meaning you can just say it's the focal point, and the pole of the mirror. The distance between this is called the focal length. Now as you can see, I drew here two mirrors. The mirror to my left side is a biconcave mirror. Alright? This is a biconcave mirror. The mirror to my left, and the mirror to my right side is a biconvex mirror. Biconvex. Alright? Now let us take a look at Fermat's principle. It is that light selects the path which takes the least time to travel. Like, you know that light goes in a straight path. But why does it go in a straight path? Because it selects the path which takes least time to travel. Alright? For example, we can say that we made a road here, and then you want to go to your house. You are right here. Alright? And then this one here is your house. Would you rather go straight to house or take a turn from here all the way here and go to your house? Or will you take this road which is going to another town and then go all the way there hundreds of kilometers away and then come back from this place which leads to your home? Or would you go in a straight path? That is what light does. It goes in a straight path. It doesn't go there, it doesn't go here, because the straight path is the smallest. So light chooses a straight path to travel. Okay, understood? So that's all for this video. Today we read about reflection of light at curved surfaces. We read about center of curvature, radius of curvature, principal axis, pole of the focus or focal point, focal length, and Fermat's principle, etc. If you have any doubts, comment down below. If you liked the video, like, share and subscribe.